Hi, it's your mentor Polinsar here. I'm bringing you the next video for polynomials. So, in the last two videos, we have discussed about the zeros of the polynomial, quadratic polynomial, and then relation between roots, zeros and the coefficients. So, today we are going to start with a very important part, but before that, we'll start with questions which were left out from the last topic. Okay, so let's start. Begin with. Okay, so without much delay, let me start with. Here it's question number 3. Find a quadratic polynomial whose sum of the zeros and product of the zeros are given by this. Can you remember in question number 2 we had the zeros, but here they have already mentioned these two quantities as the sum and the product. So your task is little less this time, because this time you need not consider the zeros, right? So this is first problem. I'll be writing the statement very completely, so you try to follow it. Let's start. Okay, so let ax square plus bx plus c, where a not equal to 0, be the quadratic polynomial. This be the quadratic polynomial. According to question, sum of zeros is equal to 1 by 4 and product of zeros is equal to minus 1, right? So now by using the relation between roots and the coefficients, zeros and the coefficients of this polynomial, what can you remember? Sum of the zeros can be written by minus b by a, which is equal to 1 by 4, and here it's your c by a, that's the product of the zeros, and that is equal to minus 1. Now just try to recall how did we find the values of a and b by comparing these relations. So for that you just have to make both the denominators same. So here you can look that this is 4, which is corresponding to the values of a. Now can you make the denominator 4 here? So you can think about the equivalence fraction, right? So by converting this 1 as a fraction with denominator 4, we can write this as 4 by 4. Minus sign is already preserved. And then you can write it like this. Now this minus can be put above here. It's better if you try to put it. Now you can go for a comparison like last time we did. So by comparing, right? Comparing, what you can write for a equals 4, you can take b. Now it's crucial. What is b equal? Look, if you compare, minus b will be equal to 1. Then what will be the value of b? It's minus 1. And the value of c, if you compare, look again, this minus should be taken with this numerator 4. So what will be the value of c? It's minus 4. So what will be your required polynomial? One of the required polynomial, it will be 4x square, then minus x minus 4. That's it. That's it. Right? So these are the steps you have to write. You have to write to complete the problem. Okay. Move on to the next. Now, just again, I'd like to tell you that I'm not going to write exactly all the statements what I wrote in the previous problem, right? Just I'll write the mathematical part and I'll get into the ultimate answer. But in order to get or qualify the complete marks, you must write all the statements very clearly during your exam, right? Okay, let's have this another problem. So here again you read the statement is same, right? The first is going to represent the sum of the zeros, the second is the product. So according to your supposition, quadratic polynomials should be like this. And never forget to write this a not equal to 0, because this is a very crucial condition. Please try to understand that. Then according to question, what I can write, sum, that is minus 2, that will be equal to minus b by a, and the product is 1 by 3, which is equal to c by a. Now you see what denominator I should bring for both the fractions. See, already there is a fraction in the right side quantity here, equation here. So what is the denominator of that right side equation? It's 3. So your responsibility is to bring here a 3, right? So if you try to put a 3 here, to balance it you have to multiply a 3. Did you get me what I say? Okay. So now if you compare what value of A you will get, this is 3, value of B will be, see, this is a minus, do not get confused with that, that minus will be transferred here and your value of B will be minus of 3 root 2 and C will be equal to 1. And then what will be your required polynomial? It is 3x squared minus 3 root 2x plus 1. That's it. This is one of the polynomial having this as a sum of its zeros and this as a product. This as the product. Okay. So move on to the next. I'm sure that you are very clear about that. Okay. Here again, this is the sum minus 1 by 4. This is the sum and this is the product. So this time I hope I'll not write a quadratic equation directly, a quadratic polynomial. I directly write the according to question conditions, right? So what I said, right, minus b by a represents the sum of the zeros, which is equal to minus 1 by 4. C by a is equal to 1 by 4. Now we are lucky this time because place of a is already filled up by 4, right? So you can get a direct comparison and you can get the value a equal to 4, then this minus will get cancelled and this will be 1, and then c also will be taking a value 1, right? So your polynomial will be 4x squared plus x plus 1. Fine. Okay. Here is the next problem. Find a quadratic polynomial whose sum of the zeros and the product of the zeros are given by this. Okay, there's a mistake, small mistake. This should have been a comma. Okay. So this time minus b by a, that is the sum is given as 0, and then what they have given, product as root over 5. Okay, I root 1. Now here also you can write 1 and then you can compare what value of a you will get, a equal to 1, what will be b, obviously 0, c will be root over 5. So your polynomial will be x squared. In place of a you will be putting 1, right? Therefore it is 1x square means x square, b will be 0, so there will be no middle term, and at last it is c, root over 5. That's it. So this time the polynomial is shorter, right? So with the help of this you can try to do exercise. Already I told you that you can now finish very easily 2.1 and 2.2. Now today what I did, this will completely finishes the related problems up to exercise 2.2. Now let me go to the theory part of the next exercise, which is again very important and very interesting, right? Let's move on to that. Okay, this is the division algorithm. Division algorithm of polynomial. Division algorithm of polynomial. So we already have in real numbers division algorithm of integers, right? Euclid's division algorithm. You can remember. So there is no big difference with the basic process. So I'm explaining you first. Let us just read what exactly the statement says. If px and zx are two polynomials, then there always exist two polynomials qx and rx such that px can be written as zx times qx plus rx. And then there is a restriction that rx can be 0 or degree of rx is strictly less than degree of gx. So this is the statement. Now I'm going to give you a good explanation about that, how these conditions are coming and how this relation is arriving at, right? So just you see, you all know the divisions. Suppose you are going to divide a polynomial px by another polynomial zx. Yeah, for division it is very necessary that this zx has to be non-zero polynomial, right? It can be a constant. So I'm dividing px by a divisor zx. Eventually there will be some quotient, and then if you carry the process of division, you will arrive at the endpoint which may give you certain remainder which we can call it as Rx. So if this is the case, how did you relate all these four quantities? Yes, exactly. This is that same old reason, same old relation, that is dividend is equal to divisor into quotient plus the remainder. So that's what we already have been using from many years, from last many years, right? So this is what the division algorithm of polynomials. Now students can easily view this particular statement. There is no problem. They can understand it very easily. But the real problem arises when you talk about Rx equal to 0, or here you see it is not and, it is or. Degree of Rx is less than degree of Gx. So I'm explaining that, then you will be able to clarify everything, right? You know, come up to this division, right? We are now going to talk about Rx. Okay, what if Zx completely divides Px? Then we'll be getting only the quotient, and in place of Rx, what will arrive at? 0, right? Meaning is that you can get such a polynomial px which is divided by zx giving a remainder 0. So one of the possibility of rx will be 0. So this is done. Now if not this is true, then this should be true, the other condition. So how will you arrive at? Let's again go for explanation. Just listen to it very carefully. Supposing that your remainder is not 0. Supposing that your remainder is not 0. Okay, if it is not 0, that means there will be some quantities left. A polynomial will be left. Now think, if you will be getting a polynomial whose degree, that is Rx degree and this degree are same. I mean to say, if your divisor had been x square plus 1 and you are saying that this is my remainder, do you feel that that will be justified? Never at all. Because to finish with the division, you must have remainder of this, degree of this quantity less than the degree of the divisor. Otherwise, your division will always proceed for one more step. Is that clear to you? Like Here if I can still continue the division for one more step. Am I clear to you? So in that case, what we'll get? Degree of Rx must be strictly less than the division. Okay, so that's very important point which you have to always remember with reference to the division algorithm of polynomials. Okay, pause the video for a little time, go through it, what I explained, and try to make sure that you are very clearly adopting what I explained, or you have understood without any problem left out. So we'll start with the problem related to division algorithm, right? So basically we have to start the problem with division of polynomial. So we had been doing it from class 9, so we'll not find much problem in division. Only thing is that the added part is to verify the division algorithm. Of course, I must say that this is a little boring part. Okay, so now let's start with the very first problem. It's fx is given as 3x squared minus x cubed minus 3x plus 5, and gx is given as x minus 1 minus x squared. And what you have to do exactly, divide fx, that means this polynomial has to be divided by this, and then you have to write what is quotient, what is remainder, and then you have to verify the division algorithm. It's quite a long problem, but not difficult. But there are certain things which you must follow, right? First of all, you have to definitely observe whether the polynomials are in its standard form or not, right? So standard form means always the power should be in the decreasing order, right? So here you can see it's a 2, that is the second degree power. There is a third cube power is here, which is not following the standard form. So your first responsibility is to rewrite this fx. How will rewrite it? You have to rewrite it in such a way that the powers of the variable becomes decreasing, right? Similarly, here also you can check it. So x square minus x square will come first, then x, then minus 1. But we alert, when you write all these, you must be sure that you are not changing the sign. Sign should be maintained. Like this was minus x square, so here also it is minus x square, right? So now we have to start with the division. This is a long division. Already you got this in your lower class, that is class 9. I think a simpler division you got in class 8 as well. So I would feel that you will not absolutely have any difficulty in understanding the division. So I'll not take much time for doing the division. Just follow it. If you'll be having any problem, definitely you connect me, right? Okay, to start the division, you look at the first term of the divisor, that is minus x squared. And what is the first term of the dividend? Minus x cubed. Now just you have to put here a value, or you can say an expression, which I multiply with minus x squared generates minus x cubed. So can you write what quantity I should put here? Yes, exactly, it is x, because if you multiply x with x squared, you will be getting x cubed, and because there is a minus, your result will be minus x cubed. Is it clear? Okay, so now once you find this, multiply by this all the three terms of the division and write the result below this dividend, right? So x into minus x squared is going to give you minus x cubed. Then this x into plus x will give you x squared, and minus 1 into x will give you minus x. And then once you finish with the multiplication, then now it's time to subtract all this from the main or the given polynomial. So now see, for your convenience, I'm writing a minus here, which reminds me of the fact that I have to minus this particular part. Okay, Now this minus is going to affect the sign of all the polynomial terms of the polynomial which we are going to subtract. So this is minus x cube. Now it becomes plus. With a pencil you can note it down so that you will not commit a mistake. Then this plus will become minus and the third minus will become plus, because one negative always changes the symbol of the terms, right? If it is plus, it makes it minus. Now just try to add them up. This is minus x cube, this is plus 3x cube, plus x cube. So they will be getting cancelled. Now this is 3x square and this is minus x square. Please see that you need not take this sign now. So 3x square minus x square generates you twice x square. Then this is minus 3x and this is plus x. Minus 3x plus x will give you minus twice x, and then you bring 5 down. Then you will be getting this new polynomial. Now, do you think that your division will proceed further? Yes, very definitely, because degree of the dividend is 2, degree of the divisor is 2, and here also degree of the dividend is again 2. So we can carry on the division further. So now can you tell me what I should multiply with this minus x square in order to obtain 2x square? Yes, exactly, it is minus of 2. If you write minus of 2 in the quotient, check this minus of 2, once you multiply with this, what exactly you are going to get? The first term will be definitely 2x square, second will be minus twice x, and the third will be plus 2. So now if you subtract, this sign will be minus, this sign will be plus, this will be minus, this will get cut, this will get cut, but 5 minus of 2 gives you 3. So what ultimately you arrived at? You have arrived after the division that qx, not gx, qx, that is the quotient, as x minus 2 and the remainder as 3. So you have to just write a final statement once you finish with the division, that therefore the quotient is qx equals x minus 2 and remainder is rx equals 3. So this is what we did, the first thing, that is only the division. And now what we are left to do it is the verification, right? To verify the division algorithm. So what was division algorithm? I'm writing here at the top, just see it. You can remember, I know that, but still. So what is division algorithm? Division algorithm is fx should be equal to zx into qx plus rx, right? So this is the single quantity in the left side, and here we have to work on this all the three quantities in the right. So let me first work on this right part, right? So now gx into qx plus rx. Just go on putting all the values and you have to now multiply. See, I'm going to leave this multiplication part for you. You will do it, you will work it out, and you will try to match the answer. Because anyway, this is a small problem and first problem of its kind. I'll be doing this. The rest you will do at home, okay? So I'm going to multiply. And do you know multiply? How to do the multiplication? Yes, one by one you have to multiply to each of the terms of the other polynomial. So I'll multiply with this polynomial, it will be comfortable. Right, this x I'll multiply with minus x square first, giving you minus x cube. This x only I'll multiply now with plus x, giving you plus x square. This x with minus 1 will give you minus x. I'm done with the first part. Now you come to the second. Minus 2 I have to multiply with minus x squared. What will I get? It is minus 2x squared. Great. Then minus 2 I have to multiply with this plus x. What will I get? Minus twice x. Then minus 2 into minus 1 is going to give you 2. And then this 3 is already here. Now just check whether you are going to get the ultimate fx or not. There is no other term except x cube, so this will be okay. Then this is plus x squared plus 2x squared added up to get this as plus 3x squared. Then minus x minus twice x gives you minus thrice x, and then ultimately this is 2 plus 3 5. Now just verify whether it is fx or not. If your divisions are correct, very comfortably it will match with fx, 100% sure. And then you can say has verified. Okay, that's it. So you pause the video again. I'm telling you, pause the video for a little time and then just observe the complete process, because the other problems I'm not going to do this part of verification, right? Okay, here's the next problem. So this time the polynomial is of degree 4, and we are lucky that this has already been arranged in the decreasing order. Okay, here you have to make an arrangement, right? It is x squared minus x plus 1. We have done the arrangement, and then we'll go for the division, right? Straight away the division. It is x to the power 4 minus 3x squared, 4x and plus 5, and the divisor is x squared minus x plus 1. Now here there is a small problem you will observe. What problem you will observe? That there is a missing power. You should have had x cube term also, but it is not there. So you need not bother about that. We'll be having a process of working it out. So we'll proceed now for finding the solution. Now to start with, I have to look for a number, a polynomial to be put here just above x to the power 4, so that this thing, if I multiply with x squared, gives me x to the power 4. What is that? Certainly it is x squared, because x squared into x squared will give you because x squared into x squared will give you x to the power 4, and then x squared minus x will give you minus x cube, and this x squared into plus 1 will give you x squared. See, there's a problem now. If we write it like this is going to create a problem for us. Why? Because this 2 we can cancel, fine, but this we cannot subtract. So purposely I wrote it like this so that you can see the situation, what we may face if we do not plan beforehand only. So I'm doing it separately. Now just check how to write this particular part. So when you have missing powers, it is better if you write the polynomials with the missing powers little loose, expanded form. Expanded form means not mathematically expanded form. The expression I am talking about, little gap should be here in the between the terms, right? Then we can insert new terms whenever needed. So now process is same. You have to start with this as x square only. You will be getting this as x to the power 4. Once you multiply x square with x square, this x square if you multiply with minus x, you will be getting minus of x cube. But as there is no term here which is minus x cube or x cube, but directly it is the next lower power. So this minus of x cube will write here, right? Which is not below x square, but between the gaps. That's what I was talking about, right? Which I did not do here. Okay, that would be confusing if you do like this. So now we have adjusted. Now you come to multiply this x square with 1. X square with 1 will give you plus x square. So now this you can write below 3x square. So you will be getting like this. Now problem is solved. Minus you put here. This will be minus, this sign will be plus, this will be minus again. Very clearly they will be cut. Now what about x cube? It becomes only x cube because there is no term at the top with this x cube. Then this is minus 3x square. Do not get confused. This sign is for minus this 3x square only. So minus 3x square, and then this is minus x square, giving you minus 4x square. And bring down this 4x, and you can bring 5 as well. There is no missing term this time, so you can write all the terms continuously. There is no problem. Now just tell me what I should write here. Yeah, exactly. There's x, because x, once you multiply with x square, you'll be generating x cube. Then multiply. Now you can carry on. Now minus x into x is going to give you minus x square, and then x into 1 is going to give you x, and then the division says this much. You do a minus here, this sign will get changed, right? I'm writing this. You can write also with the help of pencil. These are getting cut. Now this is minus 4x squared, this is plus x squared. How much you'll be getting? It is minus 3x squared. Then 4x minus 3x, sorry, 4x minus x is going to give you plus 3x, and then 5x. Now again it's time to halt for a little time and just to identify whether my process will proceed further. Yeah, exactly, because degree of this left out term, that is after subtraction what we got remainder is not remainder exactly at this particular step. What remainder I obtained is also having degree 2, and my divisor is also having degree 2. So in that case I can carry the division further for one step. What should I write here? Can you tell? Yeah, exactly, that is 3. If I write 3 here, this 3 times x square will give you how much? 3x square, but there is a minus sign in front, so it will be minus 3x square. Then minus 3 into minus x will give you plus 3x, and at last the numbers if you multiply it is minus 3. So now here also these all terms will get cut, but your what will be your numerical denominator, numerical left out? It is 8. So ultimately what will be your qx? Your qx is x square minus x, sorry, x square plus x minus 3, and rx is 8. And the verification is yours, right? Just do it. Let's have the next problem. Yes, here is the next problem. For just to get a change, we have changed the variable, right? There is no such thing involved here. Okay, I am committed a mistake in the question. This should be also t, right? This should be also t. So no problem. I'll straight away go for the division. Now though you are very clear about your divisions, so there is no problem at all in carrying out the division directly without explaining you much, right? And it is t square minus 3. Now look here, this time divisor has missing term. This is t square. t term is not there. So you might get some terms which will not match with the powers of the dividend. That's not an issue. We'll start. Let's see what we'll face, right? So how much I should put here? It is 2t square. 2t square when multiplied to t square gives you 2t to the power 4. Then 2t square when multiplied to minus 3 gives you minus 6t square. So it is t cube. So minus 6t square should be written below this 2t square. Be very alert in this part again. Otherwise, you may have to cut the whole problem. So this is all. Then you do a minus. Then this will be minus. This sign will be plus. They will be cut. Then this term is already left out. So when you do the subtraction, this time it will come. It will be 3t square. Then this is minus 2t square and plus 6t square. Together makes it plus 4t square. Then bring down this minus 90 and then bring down this minus 12. Now what you should put here? What you should put here? Yes, it is simply, sorry, this is 3t cube. So it is simply 3t. Thrice t multiplied to x square, t square gives you 3t cube. Then this 3t multiplied to minus 3 gives you minus 90. So you write below this. You will not disturb this. Now you are going to minus. This will be minus. This will be plus. Then this term will directly come out, come down here. And then this will be, yes, they will be cut if you add, because this is minus 90. This is plus 90. And then you will be left out with 12. Now what? Should I continue our divisions? Yes, we have to continue according to the division algorithm, because remainder of this term, sorry, degree of this term is 2 and degree of the divisor is also 2. So we can carry on the division process. What shall I put here? Yeah, it is 4. So this is 4t square, then minus 12. Great. This time we have finished with a polynomial where qt we got as a big polynomial, quadratic polynomial, whereas rt we get as 0. That is, remainder is 0. So other option of that division algorithm so far we did not get. This is the first problem we get. And the verification, as I told you earlier, verification is your job. Verification is your job. Do it. It is not difficult. Just you have to multiply and you have to simplify. But now I would like to just tell you that this same problem can be given in a different statement also. For example, instead of giving so big statement, I could have asked you very simply, is zx a factor of fx? And then these questions. So what exactly you have to observe? Very simple. Division 2 you have to do here also. If you divide fx by gx and you end up with rx equal to 0, like this is the case, you would say that zx is a factor of fx. And if you end up with rx not equal to 0, what will be your conclusion? Zx is not a factor of fx. That's it. That's it. Okay, here is another problem that is left for you as a homework. Good luck. Okay, so today we'll be finishing with this much only. So So see you next day with another problems, with bigger problems, with important problems. Till then, bye bye and have a good luck. Do practice.